Good day, everybody. We got a beautiful question. As usual, I would be utilizing my beautiful tool to draw the circle. Now, we got a circle here, and then let this be the center. Okay, so now we got two other circles in such a way that there is an intersection. Now, foremost, before I could draw the circle, let me draw the divider. Now, this is actually the line that is dividing this big circle into two parts. Okay, so along the center there is another circle. Okay, so this is the circle that would be in line with the center of this huge circle. So let me draw . Okay, that's fine. So you can clearly see that there is a tangent, the line that divides the huge circle. The first circle, the dark circle, actually is a tangent to the circle. Now, the same line is also a tangent to the next circle. So I will have to make sure that they are in line. Okay, that is fairly close. Okay, so this is the figure. Now, what are we to do? We are expected to find the area of this region, area of the shaded region. This is required. And what are we given? We are given that the radius of the blue circle is given to be as 1 unit, right? So let me place the center, okay, so that looks all right. Now the question comes, how are we going to get the area of the shaded region? Now, for that, the most important thing that we need to do is connect these two circles, right? So as I mentioned to you, they are along the center of the circle. So if you were to draw a line, you get a semicircle. So there is one part over here, the next part is over here. So this is a semicircle. Now let me take this part. Let me take this part as, let me use this pen. This part as some x over 2 and this part as x over 2 and this region which you see as x dash, right? So in the semicircle, if I were to, let me write the formula down. Now this is a semicircle as I mentioned to you. So area of the semicircle is actually equal to this plus this, right? So x over 2 plus x over 2 plus x dash, right? So this is going to be x plus x dash. Now area of the semicircle. Now what is this area of the circle? The area of the circle is going to be area of this circle. I'm talking about this dark circle. That's going to be pi r squared, right? But r is equal to 1 unit. The radius, all the radiuses or the radii that are in question is 1 unit. So this is going to be pi. So this is the area of the circle, but area of the semicircle you got to divide by 2, right? So therefore in this case the area of the semicircle is going to be pi divided by 2. Now this is one equation, so just have this at one corner of your mind. So this is one equation, right? We will be coming back to this. Now what I wish to do is I would like to, let me use this pen so that there is some degree of precision. Now I'm going to be connecting the two centers, right? If I were to connect the two centers and complete a rectangle, let me complete a rectangle, right? So just you take this as a rectangle, right? I know the figure is little bit aberrated, but bear with me. So this is the center, okay? This is the center, this is the center, and if I were to complete this rectangle, okay, I'm going to get a shape like this, okay? So this is a rectangle. Now as I mentioned to you, the radius is 1 unit, so this is 1 unit, this is 1 unit, from here to here this is 1 unit, this is 1 unit. So if you were to talk about the area of the rectangle, it's going to be length into width, right, or length into breadth. Now I am looking for the area of the shaded part, right? Now what I wish to bring to your attention is, if you were to consider this pi, when I say pi, or this quarter, you see that this is actually a quarter, right? And you got another quarter, there is another quarter. Now this is x dash. Now if you're looking to find the value of this x dash, can I say that from the area of the rectangle, if you can remove the two quarters, if you can get rid of this quarter and you can get rid of this quarter, you are left with this x dash. Is it okay for me to say? Yes, of course, right? Because these regions are coming inside the rectangle. So from the rectangle I need to, if I were to take away these two quarters, I would get x dash. Now what constitutes a semicircle? Definitely 2 quarters constitute a semicircle. You follow me? So if I were to get x dash, can I write this? Let me box it here. Let me write this there. X dash is nothing but area of the rectangle. From the area of the rectangle you take away the area of the semicircle, because 2 quarters constitute a semicircle. So area of semicircle. So what is the area of the rectangle? Area of the rectangle is length into breadth, right? Or length into width. So what is the length here? Length is 2 units times the width. What is the width? It's 1 unit minus the area of the semicircle. Area of the circle is pi unit. So area of the semicircle is pi over 2. So this is what you get, pi over 2. So this is equal to pi, I should say 2 negative pi over 2, which is equal to 4 negative pi over 2. So this is my x dash. So I've got my x dash. Now I can utilize 1. Therefore, 1 can be rewritten as pi over 2 is equal to x plus this quantity 4 negative pi over 2. We need only x, so therefore x is equal to pi over 2 negative or 4 negative pi over 2. This is equal to pi, LCM is 2 negative 4 positive pi. So pi is 2 pi, negative 4 divided by 2. You can take 2 out, so it's going to be pi negative 2 divided by 2. 2 gets cancelled, giving you x. So therefore, we are looking for the shaded region. This is a shaded region, this is a shaded region. So x over 2, positive x over 2 is nothing but x. So therefore, x is going to be pi negative 2 square units. So whatever units they have given us, we can take that. So this is the final solution for this question, and it's a lovely question.